Good morning, Primary 6. Great to see you all. Happy Monday. Plan for today, guys, is mainly maths. I didn't really have anything too specific to talk about, although I probably will end up, as you know, waffling about other things. But just for the sake of it, I've planned a few maths questions that I thought we would just go over as a little bit of revision. So this is just a little dip into some of the stuff that we've done previously in the year. So this is not a replacement for the maths that you should be doing today, which is on time. You should, in fact, you should prioritize that over the maths that I'm doing with you just now. And yeah, basically make sure that you're still working hard on that maths. But this is just a little bonus thing just to keep some of the skills that we've practiced in the past sharp and to do a little bit of problem solving work, because that's quite good fun to do sometimes. Just having a look over the names we've got. So we've got Alyssa and Karina and Sam and Zach, Chloe, Freddie. Good to see all of you guys. Callie, you're here. That's great. I'm going to sneeze all of a sudden. Excuse me. Chew. That was really unexpected. I apologise for that. Okay, anyway. Just a couple of things quickly. So, by Thursday, you should have read to the end of chapter 10. So this is your heads up warning. By Thursday morning or Wednesday night, if you like. By then, read to the end of chapter 10 of Wolf Brothers. So that is including all of chapter 10. There's some interesting things coming up. I think it's quite an exciting part of the story. And frankly, it just gets more and more exciting from here. But that's one of the tasks that you have to do this week. One thing about the class notebook, again, not everyone's uploading their work there. A lot of you are, but not everyone is. But one thing that we noticed earlier in the week, it was Rosalind that helped me with this. There seems to be a little refresh button sometimes that if you don't click it, it might not sync all of your stuff. So have a look for in the case of our browser, it was a little black circle with a little arrow thing inside it, which was a little refresh button that you could hit. So that's one possibility. The other possibility is you might just try clicking around and look for something that says the word sync, S-Y-N-K, S-Y-N-K? S-Y-N-C. And that should help you actually sync everything, get it all up to date and see any comments that have gone on. Because it's a little bit annoying if us teachers are spending ages typing you guys comments and feedback and then you're not actually getting them, so definitely go looking for them. And actually, to be honest, it'd be quite helpful if you just typed us a quick yes, I got that comment, or thank you for the feedback, or just something just to let us know that you're getting the feedback that we're leaving you. It just lets us know that what we're doing is being helpful. Okay? Anyway, guys, I'm just having a wee look at the comments. I'm noticing Sky saying that she can't hear me. I don't know why that is, but I trust that everyone else can because you're all responding to the sorts of things that I'm saying. Oh, and Mr. Harris has just messaged me. I'll need to get back to him. Okay, guys, right. Now, very quickly, just about your space thing for today. Your space topic today is, I think a bit of a fun task. It's kind of a problem-solving task, but there's a full explanation on it. But one question I was asked today is, at what level does gravity start to become dangerous for humans? So I can tell you that most humans would pass out at around 5 times Earth's gravity, so 5G. That would basically mean that you are 5 times heavier than you would be normally. So 1G, yeah, that's fine. That's just like being on Earth. A little bit over 1G, yeah. 2G, probably getting a bit on the heavy side. Things would be starting to become quite an effort. If you're talking 14G, yeah, you're going to be squashed flat as a pancake. 5G, it's actually, by the time you get to 5G, the gravity is pulling on you so hard that the blood from your heart doesn't get pushed up to your head hard enough, and so you pass out. So 5G is where it starts to become really problematic. So if you were wanting to look for an exoplanet and you were wondering what sort of gravity you would want, 5G would be the point at which it's becoming too much. I've just realised I'm talking about 5G here, and that could be confused with the mobile phone thing. 5G, the mobile phone thing, is not dangerous. Just to make that clear. Just in case anyone's becoming confused there. Mobile phone 5G, not dangerous at all. 5G in terms of gravity and only gravity, that is the point at which you start to pass out. The two have the same name, but are not the same thing. Just in case that I got that confused, because I would hate someone to say that the newspapers to come out with, yes, Edinburgh teacher on online to children says that 5G is bad. No, definitely not. 5G, not a problem for humans when it comes to mobile phones. Just to make that clear. Okay, guys, right. So that's your space thing today. Do a little bit of problem solving. Can you find an exoplanet that would be suitable for human life? I can tell you, I think I left one. I think there were 2 or 3 in there that could probably be suitable for human life. You just have to try and find it. Noticing someone here saying that they watched Apollo 13. Hope you enjoyed it, pal. I think it's a great film, and like I said, this is the time of year that we would be doing it. Anyone else give a shout out if they have watched Apollo 13? Because I think it is a great film. Okay, Freddie, I can't answer your questions on the help zone right now, right here, right now, because I'm on a live stream. I answer it in the help zone at the time. Okay, right. Let's move on to a bit of maths then, because I've spent quite enough time, and the main topic of this is maths revision today, so let's get to it. So I'm going to switch screens quickly to this one. Oh, and my video has disappeared. Tell you what, let's come back. Which video? Aha, there we go. Right, sorry, I'm just going to have to add my face to it here. There we are. Wonderful. Sorry, those are just my notes for the couple of things I had to talk about, so let's get that out of the way. Right, so this is the point where you can be a little bit interactive here. Join in and try to work out the problems here. So, first question. What we can see is a chart of someone's running every day. So it's just a very simple table. And we can see on Monday they ran this distance, Tuesday they ran this distance. So this is a chart showing how much David ran each day last week. Your question, which you can hopefully see, I'm hoping that I'm not taking it up. I am taking it up. I'm going to have to shrink myself here. Let's move myself to the side. But your question is, how far did he run on total on Monday and Tuesday together? So on both of those days together, how far did he run? Start working it out and try putting it in the comment section, and we're going to talk about how to work this out in just a second. So on Monday we know that he ran this distance, and on Tuesday he ran this distance. So if we're being asked how much he ran on Monday and Tuesday, we're going to need to add them together. So 3.39 plus 3.61. Now I'm doing this on a mouse tracker pad, which is really hard to write on. You guys should be very careful to line up your columns if you're doing this. So 9 plus 1 is 10. So the 0 goes there, and we carry the 1 or the 10 up into the next column. 6 plus 3 is 9, plus 1 is 10 again. And then we have 3 plus 3 is 6, plus 1 is 7. So in total, he ran 7 kilometers, and we should always have our units in there. Kilometers. Rubbish writing there. 7 kilometers on Monday and Tuesday. And hopefully, if I come to the comments, yes, there we go. I can see loads of comments saying 7 kilometers. So well done for that. One thing I will say is, don't look at the comments while you're working it out. Only look at the comments once you have typed your. Once you have worked out your answer, because I don't want you just copying each other. That way, your brain's not doing any work. You're only cheating yourself if you're copying other people's answers, which is fine. Because to be honest, I'm not judging here, but I do want you do the work as much as you can so that you're developing your understanding. Right, next question then. So same chart. How much further did he run on Tuesday than Wednesday? So this is basically the difference. Now, whenever I say the word difference, you should be thinking one particular operation. If you're working out the difference between Tuesday and Wednesday, what kind of calculation are you going to be doing? Well, we should know that that is subtraction. To work out the difference between two things, we subtract one from the other. So on Tuesday, he ran 3.61. 3.61. I'm sure some of you are already shouting it out in the comments at this point. Wednesday, he did 1.7. Now, unequal columns. That could become tricky unless we make them the same length. So 1.7, I'm going to make it 1.70. That way, my columns stay neatly lined up. So I've got 3 digits in each column. That's how I would approach it. I always try and make my columns the same length if I can. So 1 take away 0 is 1. 6 take away 7. Say it with me, guys. You can't do it. So what are we going to have to do? We're going to have to exchange. So this here is going to be scored out. It's going to become a 2. And this is going to become a 16. 16 take away 7, well, we can do that. That's 9. And 2 take away, and remember this is a 2 now, 2 take away 1 is 1. So how much further did he run on Tuesday? 1.91 kilometers. And hopefully that is what is starting to come up in the comments. Although my comments are now out of sync. There we go, it's starting to catch up a wee bit now. So not 0.31, 1.91. Being very, very careful to line up those columns and make sure you're taking the bottom one away from the top one. And if you can't do it, make sure you exchange. Okay? Important thing to work on there. But well done everyone for giving it a shot. Let's look at this final question here. So how far did David run on Sunday? Give your answer in meters. Okay, so we know that it's 0.99 kilometers. So you know what? I'm gonna do this a little bit differently. So I'm gonna make this a bit bigger. 0.9. I'll tell you what. I'm gonna spread it out, and I'm gonna put a magic decimal point in here that I should be able to move around manually. So let's do that. So it'll soon become clear what I'm doing, hopefully. Come on, there we go. Right, there we go. So he ran 0.99 kilometers. But we're being asked to say what that is in meters. Now, how many meters in a kilometer? You should be thinking 1,000. It's 1,000. The answer is basically always 1,000 for any conversions, unless it has the word centi in it. So centimeters in meters, that's 100, not 1,000. Millimeters in centimeters, that's 10, not 1,000. But anything else, if it doesn't have the word centi in it somewhere, the chances are you're multiplying or dividing by 1,000. As a rule of thumb, not 100% certain with that all the time, but as a rule of thumb, you're looking to change by a factor of 1,000. So that means we need to multiply this number by 1,000 to get it in meters. So we multiply by 10. Bop, it goes to there. We multiply by 100. Bop, it goes to there. We multiply by 1,000. Extra jump, and now there's a gap which we will have to fill with a 0. Oh no, that didn't work. Let's try that again. 0. There we go. So, in that case, how many meters did he run? Well, this is the units column, the tens column, the hundreds column, and the thousands column. So no thousands. It wasn't quite 1,000 meters. It was 990 meters. So in total, he ran 990 meters. And that is how we work that one out. Coming to the comments, are we seeing it? Zach was first up there as far as I can see. Some people saying 99, and I can see why you're saying that, but it wouldn't be 99 because remember we're multiplying it by a factor of 1,000. So it is 990 meters, not miles. If he's running 990 miles, he is one fit guy to do that in one day. 990 meters. Okay, guys. So that is enough of David and his running habits. Let's go on to the next question. So this one is a little bit of information handling. We have this is the names of ages, and weights of some animals here. I think they were meant to be cats. These are different cats here. So we've got Bandit, Biffy, Bix, and Bruce, and we're being asked to work out which of these crosses corresponds to which of these cats. So all I want you to do is, looking at them, try to tell me which cat is cat A on the graph here, which cat is cat B on the graph here. So working this out, hopefully you can start figuring it out here. Cat A, well, what are we seeing? He is 9 years old. Okay, he's bang on the 9 years line. And he's 3.5-ish kilograms even. 3.5-ish kilograms. So let's have a look. Have we got a cat that is 9 years old? Oh, well, yes, we do. So, and yep, right enough, 3.6 kilograms. So this one here must be Biffy. There we go. So we worked that one out straight away. Hopefully you're well on your way to doing the other ones. So this cat here, cat B, well, he's 3 years old. And frankly, that's enough for us to work it out. The only cat that's 3 years old is Bix here. Which means if Biffy, Bandit, and Bix are already done, the only one remaining should be Bruce. But let's double check it. We can see, according to this, it's not quite a year old. And right enough, 10 months isn't quite a year. And he's a bit over 4 kilograms, coming up for 4.5 kilograms. So, and yeah, what do we know? That's 4.3 kilograms. So that would be about right. We should be able to work out that C is Bruce. There we go, guys. So that is how we're able to work out that problem there. Okay. I'm very conscious that my face is only half on the screen. I need to lean over this way to be more visible to you guys. Right. Let's move on to another problem. Fractions. One of my favorites to work with. Now, you should know that fractions are just fancy division sums. And if we're looking to compare fractions, which is what we're being asked to do here, there is one thing that we want to do to those fractions to compare them. Okay? So, these fractions, we're being told, all have the same value except one of them. One of them is the odd one out. What we need to do, let's ignore this part down here just now. That's a challenge for later. But first of all, we need to spot the odd one out. And to do that, the simplest thing to do is to simplify all of them. So, you could start with 75/100ths if you wanted, but that one might be a little bit tricky in some cases. But, 75/100ths, if I was going to do that, I'd be using my 25 times table to do that. I know that sounds a bit complicated, but the 25 times table is really easy. 25, 50, 75, 100. That's basically it, up to 100 there. So, what's the top number then? 75 divided by 25. So 25, 50, 75. It's 3. Okay, so the top number of this one is 3. What about the bottom number then? 25, 50, 75, 100. Oh, it's 4. Right, so far we've worked out these two are the same. Right, let's try some more here. This one is already simplified as far as it can be. What about this one here? 6/8. Well, both of those, let's think of a times table that they're both in. We want a times table that 6 and 8 are both in. 2 times table. Obviously, it's the 2 times table. So we divide both of them by 2. 6 divided by 2, 2, 4, 6. 3 again. And 8 divided by 2, 2, 4, 6, 8. That's 4. So again, it's 3/4. And we're starting to see that so far all of these are equal. All of those are equal there. 2/3. Well, that's as simple as it gets. So to me right now, it's looking like this one is the odd one out. That's already as simple as it gets, and 2/3 is different from 3/4. But let's double check it. We're going to simplify this one. What times table could we use? We could use the 2 times table again, but you know what? The 4 times table will be even easier because that'll simplify it straight away. So 12. How many 4s are there in 12? 4, 8, 12. 3 of them. And you can figure out the way this one's going. How many 4s are in 16? 4, 8, 12, 16. 4 of them. So the odd one out here is 2/3. Now we're being asked, write another fraction with the same value as the other 4 fractions. So in other words, write something that is the same as 3/4. So we need to write another fraction, I did that horribly there, another fraction which is the same as 3/4. Basically, you could multiply the top and the bottom number by any other number and you will get an equivalent fraction. So, if I multiply them by 2, I get 6/8, but that's been done already. Let's multiply them by 3. 3 times 3 is 9. 4 times 3 is 12. And there we go, an equivalent fraction. 3/4, 9/12. In the comments, try to throw up another few. You might go for something like 30 40ths, multiplying both of them by 10. I suppose you could go 90 120ths. You could do simpler ones. You could multiply them both by 5 and you would get 15 20ths. There's any number of different fractions that you could possibly get there. Okay? Anyway, guys, I'm just letting the comments catch up here because I've just clicked back to the comments screen and my comments are a little bit behind where you guys are. But no worries, that's fine. I'll catch up at some later stage. I can't actually see your comments up to date. I'll need to review them later. But let's go over another question here. We're probably not going to get through all these questions today because we're only about halfway, or we're just coming up for halfway through this flip chart here. So we'll probably resume this on another day, but hopefully it's good just to do a bit of revision. So let's get rid of those 2 questions. We're going to work through these one at a time. So here are some rods of different lengths. Now if we want to work out the lengths, we can just count the boxes. So this one is 1, 2, 3, 4, 5, 6, 7, 8 boxes long. This one is 2, 4, 6 boxes long, so on and so forth. Now we're being asked, to start with, which rod is 2/3 of rod B? Well, first of all, how long is rod B? 1, 2, 3, 4, 5, 6. Okay, so rod B is 6 boxes long. What we're being asked is which rod is 2/3 of that. So effectively, we're being asked to work out 2/3 of 6. So how do we do that? Well, with any fraction, we divide by the bottom, multiply by the top, because that's what fractions are. The bottom number tells you how many equal bits you're splitting it into. So we're going to take 6 and we're going to split it into 3 equal bits, or in other words, divide it by 3. The top number tells you how many of those bits we're taking. So 6 divided by 3, we'll do our 3 times table until we get to 6. So 3, 6. Okay, 2. That simple. So 1/3, I'll write that, 1/3 of 6 equals 2. So 2/3 of 6 is going to be 2 lots of that. 2 plus 2, well, that's going to be 4. So which of these is 4 boxes long? To me, it looks like E. So which rod is 2/3 of B? It is E. Next question. Which rod is 50% of A? Oh, wee bit of percentages here, but 50% is an easy one. So it's half, basically. So if rod A is 8 boxes long, we're being asked which one is half of 8. So 4 boxes long again. And once again, it's E. Same thing, because that's 4 boxes long. Only one that's 4 boxes long. Lastly then, and this one's a little bit trickier, but not really. You just need to think about it. Fill in the fraction. Rod A is what fraction of rod C? So we're being asked to fill in a couple of numbers here. We're being asked to fill in a numerator and a denominator in order to say what the fraction relationship is between them. So rod A we know is 8. Rod C is 10 boxes long. So C is 10. A is 8. So we could say that rod A is 8/10 of rod C. However, the sharp ones among you will be thinking, we can simplify that. So we divide the top and the bottom by the same number, and what do we get? We get 4/5. So rod A is 4/5 of rod C. Both of these are correct answers. It's just one is a bit more correct than the other, if you like. Okay, guys, we're going to squeeze in one last question. And this is quite a nice one, I think. It's a good one to end on. So, each of... Sorry. I don't know why it's each of the... There was obviously a question that came before this. But here we go. 36 pupils will be given a bag of crisps. The crisps are sold in boxes of 8 bags. So, we got 36 pupils in the class. They're all going to be given a bag of crisps each. And the teacher, me, can go away and buy crisps in bags or in boxes of 8 bags a time. We're being asked, first of all, how many boxes will we need? So, let's think about this in this way. If I buy... let's do that. Here we go. There's a box of crisps, and it has 8 bags in it. So if I just buy one box, I've only got enough for 8 kids. What if I buy 2 boxes? Well, now I've got enough for 16 kids. Not quite enough, but a little bit better. What about 3 boxes? Well, that's going to be enough for 24 kids. We're getting closer. Let's add another 8 on there. How many do we have now? Well, that's 4 times 8. Well, that's 32. Is that enough for all 36 kids? Not quite. So I think if we just get one more, that's going to be 5 boxes, which is 5 times 8. 5 times 8, well, that is 40, isn't it? Right, 40. Will that be enough? Yeah, that would definitely be enough. So how many boxes will we need? We'll need 5 boxes. Ooh, 5 boxes. Now, how could we work that out mathematically? All I would do is I would just count up in 8s until I go over 36. So I go 8, 16, 24, 32, 40. Oh, I'm over it by the time I get to the 5th station, so 5 times 8. That's a very simple way of working it out mathematically. So, how many boxes will we need? 5 of them. How many bags of crisps will be left over then? So if I've bought 40 and I'm only using 36 of them, I've got a sum to do there, and it's 40 take away 36. So how many will be left over? 4. 4 bags left over. It's really that simple. If you know your times tables and you know how to subtract, you can work out questions like this, no problem at all. Anyway, guys, we're going to stop there just now. Hopefully you've been able to follow along a little bit. I've kind of not been paying too much attention to the comments here, unfortunately, today, because I've just been working through it on the screen. However, like I said before, this is not a replacement for your standard maths today. This week we are going to be working mainly on time. Quick problem. A couple of you said that you were struggling to access Miss Lindsay's link on the maths. A couple of things that you can do to solve that. One would be to copy the link, so highlight it and click copy. But to be honest, even I was having a little bit of trouble with that earlier. So if you're on a computer, what you should be able to do is hold the control key, the CTRL key, and then click on the link. And that will then take you to Miss Lindsay's link. Okay, so as long as you're holding control and then click the link, then it'll be fine. Okay, so that is my bit of advice for you guys there. Anyway, guys, we're going to sign off just now. Work hard today. It is at last a nice day. We've not had a nice day all weekend, but now when we're due to go back to work, we're getting nice weather again. So I suppose go out and try and enjoy the sunshine a little bit while you can. Anyway, I'm going to sign off just now. And yeah, work hard. Take care. And I'll see you... Oh, sorry. One thing I missed. I'm only doing one group meeting today. So from now on for my class, because we've not been getting as much attendance at the other ones, instead of meeting you in your reading groups, I'm going to have a couple of opt-in meetings on a couple of the days. So at 11 o'clock on a Monday and 11 o'clock on a Wednesday, there are going to be general meetups. Anyone can come to them. There's no obligation to come to them, but anyone is allowed to come to them at any point. You just turn up. Doesn't have to be your usual day. But if you turn up, we'll then go through any questions that you have and all that sort of thing. Okay, Rosalind, I don't know if there's a meeting today. I'll try and answer any other questions at 11 o'clock when we meet up. Okay. Anyway, guys, see some of you at 11 o'clock if you have something to bring to the meeting. If you have a question to ask, and failing that, I'll see the rest of you on Wednesday. Take care, guys. Speak to you soon.